Hello everyone, my name is Victor and I will be presenting the paper Guideline Bias in Wizard of Oz Dialogue, which is worked on together with my supervisor Søgaard. When collecting a dataset for a task-oriented dialogue task, i.e. some task where a user interacts with an automated agent to achieve a certain goal, such as booking a restaurant, a popular setup is the so-called Wizard of Oz method. Here, the crowdsourcers will play the role of both the user as well as the automated agent in order to simulate a conversation between the user and the system. Both the user as well as the agent will follow some pre-specified guidelines where the user goals and the questions the agents need to ask are defined. These annotation guidelines are intended to train the annotators and therefore, in some sense, also prime them for better or for worse. And what we focus on in this paper is on the unintended bias that arises from how these guidelines are formulated, which is what we choose to refer to as guideline bias. We examine occurrences of guideline bias that stem from two different data sets collected using the Wizard of Oz setup. Although we stress that the concept of guideline bias is not limited to the dialogue domain. The first is the coached conversational preference elicitation dataset, where we examine two things. First, how a lexical bias and the guidelines can influence the annotators, and what the downstream effect of this lexical bias means for the model's ability to generalize. The second is the Taskmaster1 dataset, where we analyze how the order of the described goals in the guideline influence the structure of the conversation. Our first example is the CCPE-M dataset, where an agent seeks to extract movie preferences from the user by asking them a series of questions. We are here motivated by a lexical bias, namely the overwhelming use of the verb like in the guidelines, as highlighted on the right. Here, more than 50% of the sentences contain inflections of like. 72% of the agents will use like in their first dialogue turn, and when they do, more than 50% of the users also respond with a form of like. The assumption here is that this contributes to an overly optimistic estimate of the model's performance, as it hinders generalization towards alternative phrasings of preference expressions. We study the priming effect the guidelines have on the user responses by conducting a small crowdsourced experiments using Amazon Mechanical Turk. We asked different people what kind of movies they either like, love, or prefer, and we observe the verb mentions in the responses. And what we see is that given one of these priming verbs, the users are much more inclined to respond with the same verb to describe their preference. In our case, between 50 and 60% more likely. This shows that the phrasings of the guidelines matter for the resulting data collection process. The CCPE-M dataset consists of annotated conversations between users and agents. And they label spans if they contain a preference of either movies, genres, actors, or if no preference is available. And to study the downstream effect of this lexical guideline bias, we simplify this task a bit by framing it as a sentence classification task. I.e. if a sentence contains a labeled span or a user preference, or a none if no preference is detected in the sentence. We then proceed to create 5 different test sets in total. 1 unchanged from the original CCPE-M dataset, and 4 where we replace the instances of adverbial like with synonymous words or phrases. And these different phrases are love, was incredibly affected by, have is my all-time favorite movie, am out of this world passionate about. And we note that our heuristics does not always produce grammatically correct sentences, but the words and phrases should produce the same, if not a stronger sentiment towards a user preference. Additionally, we also collect a smaller out-of-domain test set where we scrape comments from Reddit threads that discuss movie preferences. In general, we get a more even distribution of verbs used to describe movie preferences, and the occurrence of like is much less frequent here. We then proceed to annotate the data according to the annotation instructions provided by the authors. We train 2 different models on our data, namely a bidirectional LSTM and a BERT-based model. And we measure the performance using class-weighted F1 score. The models are evaluated on our unchanged test set, our augmented test sets, and our out-of-domain test set. And overall, we can see that BERT generally performs better on our benchmarks. And for both models, we observe a drop in the performance when examples are perturbed and the word like is replaced with the synonymous phrasings. Especially when like is replaced with longer phrases, the models see a bigger drop in performance, with the bidirectional LSTM being especially sensitive to these augmentations. Both models also see a significant loss in performance on our out-of-domain benchmark, up to 30% for the LSTM and 13% for BERT. To combat this lexical bias of the guidelines, we propose a simple method to create a less biased resource. We use 6 different paraphrases of the verb like listed in a publicly available thesaurus, and none of which overlap with the words used to perturb the test data. And we randomly replace verbal like with a probability of 20%. The word or phrase we replace like with is sampled from a uniform distribution. And we can see that the 6 different words or phrases are derive pleasure from, get a kick out of, appreciate, take an interest in, cherish, or find appealing. And we see that when training on our debiased resource, both models become more invariant to our perturbations with up to 4.5 F1 points improvement for the BERT model and 3 F1 point improvement for the LSTM without any loss of performance on the original test set. We also observe improvements on our collected out-of-domain data, suggesting that the initial drop in performance can be partially explained by the guideline bias and not only the domain differences. We stress that this is not intended as a solution to the guideline bias, but in our experiments, we show that a model trained on this simple debiased dataset generalizes better to out-of-sample data, showing that this bias towards like was in fact one of the reasons that our baseline classifier performed poorly in this domain. The order in which the goals of the conversation is described to the annotators and the guidelines can also bias the order in which these goals are pursued in the conversation. we examine this phenomena in the Taskmaster 1 dataset. Taskmaster 1 consists of conversations between a user and an agent, where the user seeks to accomplish a goal by booking tickets to a movie. The guideline specifies a series of requirements the user needs to log in during the conversation, such as the movie title, the theater name, and the city of the theater. And the idea here is that when booking tickets to go see a movie, we could specify any of these goals before one before another. But models may not become robust to such variation if only exposed to very biased examples. To quantify this guideline bias here, we compute the relative probability that a goal is mentioned before another one in a dialogue, given that the guideline does so as well. For example, if the movie title goal is mentioned before the theater name goal in the guideline, does the same also hold for the downstream conversation? The Taskmaster 1 dataset was collected using two different sets of guidelines in order to reduce bias, and we can therefore investigate the downstream effects of the bias induced by these two sets. We here show the heat maps of the relative probabilities, and we can see that the guidelines have a clear influence on the final structure of the conversation. For example, in Guideline 1, if the movie title is mentioned before the city and the guidelines, there is also a high probability, in this case 75%, that the same is true in the dialogue. In Guideline 2, they are not, and therefore we observe a much lower probability here, only 57%. So, in conclusion, we examined guideline bias in two newly presented Wizard of Oz style dialogue corpora. And we show how a lexical bias for the verb like in the guidelines can lead to a bias for this word in the dialogue. And we can see how it influences the model performance when there is an absence of this word. And we show that this can be somewhat mitigated with a data augmentation strategy. And we lastly analyze how the order of the guideline goals affect the structure of the final conversation. Thank you.